So section 10.2, we're going to take our sine and cosine graphs and we're going to add a little phase shift to it. We're also going to learn how to graph tangent. Let's remember what cosine of theta looks like when you graph it. Cosine of theta has a period length of 2 pi. It touches the midline 3/4 and 1/4 of the way through the period. It's above the midline at the beginning and end of the period, and halfway through the period it's below the midline. It has an amplitude of 1 because it goes above and below the midline by 1 unit. Sine touches the midline at the beginning, middle, and end of the period. 1/4 of the way through it's 1 above, and 3/4 of the way through it's 1 below. Its period is also 2 pi. So let's review what all these letters do to the parent graph. This A value, if it's negative, it's going to make a vertical reflection. If its absolute value is greater than 1, it's going to stretch the graph vertically. If its absolute value is between 0 and 1, it's going to shrink it vertically. Let's talk about B. If B is negative, it's going to be a horizontal reflection. If its absolute value is bigger than 1, it's going to be a horizontal shrink. If its absolute value is between 0 and 1, it's a horizontal stretch. This H value is a phase shift. It translates the graph left or right. And K is the vertical displacement. It translates the graph up or down so many units. Let's do number 1. We're supposed to graph this function. Please note, as this shows up here, we want the coefficient of x to be a 1. And that's how this problem is. The A value for this problem is a 1. The amplitude is the absolute value of that, which is also a 1. The phase shift for this is x minus a negative pi over 4. Notice how the parent is written. It's supposed to be x minus a number. We are subtracting negative pi over 4, so the phase shift is negative pi over 4. The period length for this is 4 pi, and the reason is this 1/2, this is between 0 and 1, it stretches the graph by the reciprocal of that number, which is 2. So if the normal period is 2 pi, and we double it, it's going to be 4 pi. Vertical displacement is the number that we're adding or subtracting at the end, and that's a 0. This does not go up or down. Okay, so how do we do this? First of all, if we're trying to fit a complete period into this, and it normally starts at 0, we're supposed to go to 4 pi. We don't have enough space for that. So if you'd be kind enough, you can just kind of cross these numbers off. I'm going to make a different y-axis. I'm going to strategically put my y-axis right here. You'll see why in a moment. I'm not going to change the scale of the graph. Every 4 spaces was pi, and I'm going to still make every 4 spaces pi. Always graph your midline first. Our midline is y equals 0. That is affected by the vertical displacement. Vertical displacement 0, so our midline is still 0. Then, this part's new, you have to incorporate your phase shift next. Our graph normally starts at 0, but since our phase shift is negative pi over 4, it's going to start at negative pi over 4. Well, how big is pi over 4? It's 1/4 of pi. Pi is 4 units, so that means pi over 4 is 1 unit. So here's what this means for us. Let me recap what we've done. After you identify the midline, use the phase shift to figure out where your period starts, and then figure out where it ends. So check this out. Don't draw this yet. If the period started at 0, it would go all the way to 4 pi. But it doesn't start at 0. It's translated to the left pi over 4, which means the period's going to end right before we get to 4 pi on the graph. But the overall length for this is 4 pi. This is one period. On your midline, figure out where the beginning of the period is. It's right here. Where the end of it is. It's right here. Where halfway is. I can count spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. There's 16 spaces. Halfway through is going to be 8, which is right here. Quarter of the way through is going to be 4 spaces. 3/4 of the way is going to be 12 spaces. So don't draw this next part. Just want to make sure this is kind of clear. Each of these segments are 4 units long, equally spaced. If it's not equally spaced, it's not going to look right. If it doesn't look right, then it cannot be right. So once again, identify the midline. Figure out where the period starts and ends, and then mark every quarter of the period. From memory, we should know that cosine touches the midline 1/4 of the way through the period and 3/4 of the way through the period. Cosine is above the midline at the beginning and end of the period. It's below the midline halfway through. Since our amplitude was 1, those y values do not change. They're just up and down 1. So this part here is concave up. This part here is concave down. We have just graphed our very first cosine with a phase shift. Let's check out number 2. So we have a big problem with number 2. It is colossal. The coefficient of x is supposed to be a 1, but it's not. It's a 2. So how do we fix that? We are going to factor a 2 out of this. Now this 2 is still part of the angle. So if I factor a 2 out, that means I'm going to divide 2x by 2 and get x. I'm going to divide pi by 2 and get pi over 2. If when you're finished, you're thinking, I'm not sure if I did that right, in your head, multiply this back out and see if you get the original. We are now in business to be able to accomplish this. A in this problem is a -2. It means it's going to reflect the graph vertically. It's also going to stretch the graph vertically by 2. The amplitude is the absolute value of that. That is worthless information to graph this. The phase shift is pi over 2. It's whatever you're subtracting from x, as long as the coefficient of x is 1. The period for this 2 shrinks the graph horizontally by the reciprocal of 2 by 1/2. So what that means is the period was 2 pi. It gets cut in half. The period is now pi. Vertical displacement is the number you're adding or subtracting at the end. That's a -1, so everything shifts down 1. Once you've identified those things, see if you can fit one period on this graph. We sure can. Then graph the midline. I like to make my midline with a dashed segment. Midline is y equals -1. Then use the phase shift to figure out where this period's going to start. Since the phase shift is pi over 2, it's going to start here at pi over 2. When does the period end? It ends pi units later. So how long is pi on this? It's 4 spaces. So if I start at my beginning and I go to the right, 1, 2, 3, 4 spaces, this represents one period of this graph. When we know where it starts and it ends, mark the middle of the period, mark 1/4, and mark 3/4. Now what's supposed to happen? Sine is supposed to touch the midline at the beginning of the period, halfway through the period, and the end of the period. 1/4 of the way through the period, sine is supposed to go up 1 unit. But since a is -2, it's going to go in the opposite direction 2 units. Normally, for the parent graph of sine, 3/4 of the way, we're supposed to go down 1. Since a is a -2, we're going to go up 2. This represents 1 period of the sine graph with a phase shift of pi/2. I would like you to graph this for as long as we have graph, as long as we have space. So every 1 unit horizontally, something's happening. It's going to alternate from on the midline to above it to on the midline to below it. If it's above the midline, it's concave down. If it's below the midline, it's concave up. Just going to change this color so we can see that is 1 period. And then the rest of it is just filling the rest of it in. So not so bad, not so bad. Let's look at number 3. We're supposed to write the equation of the sine curve to the right using a positive lead coefficient A and the closest phase shift possible. So every time you do this, you could do this first. Y equals blank, sine, bracket, some number, parentheses, theta, minus some number, brackets, plus some number. Let's do the phase, no, let's not do the phase shift. Let's do vertical displacement first. This graph goes as high as 4 and as low as -2. Well, the midline is going to be halfway between that. So the midline here is at y equals 1. If the midline is y equals 1, that means vertical displacement is 1. Now let's figure out our A value for this. It says that we want a positive lead coefficient A. So normally you go up 1 from the midline, we're going up 3, so that means A is a 3. Not so bad. What about the period length? So if you remember that I keep saying tangent, sine touches the midline at the beginning, middle, and end of the period. So we could count this part of the graph as 1 period. Now somebody else could come along and say, well, I would like to count this as 1 period. That's fine, you can do that. They're both correct. So it looks like my period length, if I were to take this and just translate it over, is pi. Starts at pi/4 and ends at 5 pi/4. So that means the horizontal length of this is pi. The parent's period is 2 pi. If you multiply that by some number k, then that's going to be the period length for this. And this period length for this is pi. So that means that k is going to be pi divided by 2 pi, so k is a half. So that means, are we using k for this? I'm sorry, we're using b for this, not a k. And I just did that backwards. My apologies. It's a snow day. Since the period got cut in half, that means this is going to be a 2. So that means if we take the parent's period, that should be equal to b times the new period. So 2 pi is b, the new period is pi. If you divide both sides by pi, you get b is 2. So my apologies for doing that wrong the first time. I just wasted some of your time. Now let's factor in the phase shift. If I'm saying the graph is starting here, that means the phase shift is pi over 4. Done. If you wanted the period to start here and make your graph like this, then this would be theta plus pi over 4. Technically, they're both correct. All right, let's get to tangent. So we did phase shift for sine and cosine. Let's talk about the tangent graph. So if tangent is this function f here, tangent of 0 is y over x. That's 0 over 1, which is 0. Tangent of pi over 4, that's going to be square root of 2 over 2 over square root of 2 over 2, which is 1. Getting all this from the unit circle. And then tangent of pi over 2 is going to be y over x. That's 1 over 0, which is undefined. And then 3 pi over 4 is going to be square root of 2 over 2, negative square root of 2 over 2, which is negative 1. And then pi is going to be 0 again, because it's 0 over 1. If we continue this, we're going to get 0, undefined, negative 1, and 0. Getting all this because tangent of theta is sine of theta over cosine of theta, which is y over x. So let's use these points and let's graph it over here. The tangent parent graph function. So we said at 0, it's 0. At pi over 4, it's 1. At pi over 2, it's undefined. To graph undefined, that's a vertical asymptote. Then at 3 pi over 4, it was negative 1. Then at pi, it was 0. Then at 5 pi over 4, it was 1. And then 3 pi over 2, it's a vertical asymptote. And then at 3 pi over 2, it's undefined. I just said that. And then 7 pi over 4 is negative 1. And then 2 pi is 0. Hopefully, you can see the pattern of what's happening here. This is what the curve's going to look like. Notice this is the part that's going to be repeating. The horizontal length of this is 1 pi. Here we've got a partial graph. The other part's going to be here. Here's another partial. This just keeps repeating itself. I got this messed up. Yeah. This should be over here like so. So this is tangent. And here's what we need to memorize for the period. 1, the period for this is pi. Now that's much different than sine and cosine. Sine and cosine has a period of 2 pi. Tangent touches the midline at the beginning and end of the period. You can see that, beginning and end. Halfway through, it's a vertical asymptote. A quarter of the way through, it's 1 above, and 3/4 of the way through, it's 1 below. Standard equation for tangent, we can see here, it's got all the same ingredients that it has on the other side. This is a vertical stretch or shrink, reflects it vertically. Horizontal stretch or shrink, reflects it horizontally. Phase shift translates it left or right. A vertical displacement, up or down. Once again, the period for this is pi. Let's graph one of these, see if we can do this. I have a problem here with this, and the problem is the coefficient of x needs to be a 2. If I factor a 2 out, that's going to make this pi over 2. The period for this is normally pi, but since this 2 is hanging around, it's going to shrink it horizontally by 2, which makes the period just pi. Phase shift for this is negative pi over 2. There is no amplitude. There is an a value. It's a half. Amplitude is the absolute value of that. That never helps us graph it. It's just a word. Let's identify the midline. Since the vertical displacement for this is 0, the midline is y equals 0. Then let's start out with a phase shift of negative pi over, the phase shift is positive pi over 2, not negative. Let me emphasize this. This is x minus a positive pi over 2. So the phase shift is a positive pi over 2. So our graph is going to start, one period is going to start at pi over 2. Our period length is, I messed that up too. I'm sorry. I'm not having a good day. The parent period for tangent is pi. This 2 cuts that in half. That makes this pi over 2. Oh boy, I wish I could edit this video. I have messed up a lot. So if we start at pi over 2, and the period length is pi over 2, that's going to get us to pi. This is one period. We're going to mark on the midline at the beginning, middle, and end. We're going to also mark a quarter of the way through the period and 3/4 of the way through the period. All this magic is happening in this tiny, tiny space. I like to do vertical asymptotes first. Tangent has a vertical asymptote halfway through the period. From memory, the beginning and end of the period of tangent is on the midline. A quarter of the way through, it's 1 above. 3/4 of the way through, it's 1 below. Since our A is a half, we're going to go up a half and down a half, making the scale a 1. That means my curve looks like this and looks like this. Do not only graph one period. If we continue this pattern, we're going to have a curve that looks like this with another vertical asymptote. This little fella right here just keeps getting repeated. Over and over and over. This is getting tedious, so let's make this roll. I want you to graph at least, if the space permits it, at least 2 periods. And make them complete curved periods. So we're starting in here, 2 periods is here, but finish the curves. All right, almost finished. I know this has taken way longer than we all hoped it would have. How do you reduce complex fractions? Well, I like to multiply by 1 in the form of the least common denominator. 10 over 10 is the same as 1. 10 divided by 10 cancels, we get 3. On the top, 10 divided by 5 is 2. 2 times 2 is 4. This is 4/3. This one here, I'm going to multiply. This is not the least common denominator. Multiply by cosine over cosine, that's the same as 1. On the bottom, those cancel. On the top, you get cosine of x over sine of x. And hopefully you know, or you'll know shortly, that's the same thing as cotangent. Well, this is not a complex fraction. What are we talking about? Well, cosecant is the same as sine of theta, 1 over sine of theta. Cotangent is the same as cosine of theta over sine of theta. Probably all news to you, but pretty soon that's going to be second nature. Want to get rid of our complex fraction, I'm going to multiply by 1 by a form of 1 in sine over sine. Those cancel, We end up with 1 over cosine of theta, which is secant of theta. How do you add and subtract fractions? We need common denominators. I'm going to multiply this by 1 in the form of 2 over 2, and this one by 1 in the form of 5 over 5. That's going to give us 6/10 plus 5/10. Once you have common denominators, add the numerators, leave the bottoms the same. This one, if we multiply by 1 in the form of cosine over cosine, and here 5 over 5, we're going to get 5 over cosine of x plus cosine of x over cosine of x, which is going to give us 5 plus cosine of x over cosine of x. They're not like terms, so we cannot combine the 5 and the cosine. Here, we can multiply this by sine of theta over sine of theta. That's going to give us sine of theta over sine of theta minus 1 over sine of theta. I'm sorry, it's going to be sine of theta squared, which is sine squared of theta minus 1 over sine squared of theta. Not squared, just sine. All right, that's it. That's the end of the notes. Do the homework 10.2. I'm sorry this was a video. Have a nice snow day.